Let's have a look at Wi-Fi analyzers and how to conduct a Wi-Fi site survey. A Wi-Fi analyzer scans for Wi-Fi networks. It can be a specialized device or software running on a laptop or mobile device. For example, you could use a Wi-Fi analyzer on your mobile device to detect other networks in your area. A Wi-Fi analyzer scans for Wi-Fi networks and tells you things such as what other Wi-Fi networks are in range, signal strength, and how congested the Wi-Fi network is. Given this information, you will be able to make decisions about what you can do to improve your Wi-Fi network. In order to find out where the problems on your wireless network are, you may want to conduct or pay someone to do a wireless site survey. A wireless site survey identifies signal strengths and coverage. This will help you identify dead spots or areas of network congestion. Wireless site surveys are often done to create a baseline. This is normally done during typical network usage. Don't make the mistake of doing these outside business hours when no one is using the network. You want the baseline to tell you how the network is performing when loaded and what problems there may be. The wireless site survey is often used to make changes or upgrades. For example, doing a wireless site survey can identify dead spots on the network. By conducting a site survey, you can show your boss where the dead spots are and hopefully get an access point added to that area of the network. Wi-Fi signal strength is measured in decibel milliwatts or dBm. This is a unit of measurement expressing the power of a signal relative to a specific reference point of 1 milliwatt. It can be difficult to understand how this value is calculated, so if you are not concerned about how it is measured, know that signal strengths are measured from 0 to -100 dBm. When working with Wi-Fi signals, the following will guide you on how strong the signal is. Understanding the calculation behind dBm is not crucial if you are comfortable interpreting the information visually through the graph. This way, you can still gain valuable insights about signal strength without delving into the technical details. Understanding how dBm is calculated is not necessary. You don't need to know it, so don't worry about spending time trying to understand it unless you are interested. As a signal travels, encountering obstacles or covering longer distances, the signal is weakened. When measuring signal strength, 0 is considered a signal strength of 1 milliwatt. In the real world, you won't get a signal strength of 0. Thus, all signal measures have 1 subtracted from them, and this is why we get negative values. The dBm is calculated using a logarithmic function. Lower negative values mean more signal loss, so, put simply, you measure the signal strength by subtracting 1 milliwatt from your reading. A logarithmic function is used to make the result more meaningful and easier to understand. You may be wondering if it is possible to get a signal strength greater than 0. This should never happen with standard consumer Wi-Fi equipment. Wireless communication is heavily regulated, including how strong the signal can be. Thus, standard consumer equipment will not go above 0. While the official study guide mentions signal-to-noise ratio, or SNR, I doubt you will be tested on it in the exam. SNR reflects the strength of the signal compared with the level of background noise. Imagine watching TV with annoying background chatter. The louder the chatter, the harder it is to hear the TV. If you want to listen to the TV, you can reduce the chatter or turn up the TV. Similarly, a strong signal can easily overcome minor noise, but a weak signal is easily disrupted by even moderate interference. SNR tells us how noise is affecting your signal. To measure signal-to-noise ratio, you require a hardware Wi-Fi analyzer. Software analyzers do not generally have this feature, and if they do, the software will generally estimate it rather than measure it directly. If you don't want to buy a hardware Wi-Fi analyzer, there are plenty of software ones that are available. I will be having a look at a software Wi-Fi analyzer which is freely available open source software. It is good software for measuring your Wi-Fi signal. It is not so good for conducting site surveys, but great if you just want to test what your Wi-Fi signal strength is and see what other Wi-Fi is being used near you. In our previous videos, we recommended keeping your router settings on auto. This allows the router to intelligently monitor the network and adjust settings as needed, ensuring optimal performance without requiring manual intervention. This means you don't need to know what other Wi-Fi networks may be interfering with your Wi-Fi network. But the time has come. We are removing the bag and showing you exactly what a Wi-Fi network looks like in a typical residential building. I will start up the application on my Android mobile phone. The Access Points tab shows all the Wi-Fi access points that it has picked up. At the top, there is a message saying Wi-Fi scan throttling is enabled. Android devices will limit the number of Wi-Fi scans that can be performed in a set time period. This needs to be disabled in developer options in order to allow more scans to occur in a shorter time period. Later in this video, I will look at how to disable this option so scans won't be limited. You will notice how many it has picked up. If you live in an apartment building nowadays, there is going to be a lot of Wi-Fi. Most will be using the default Wi-Fi name. I would recommend changing this so an attacker has less information when trying to find a vulnerability in your router. Some Wi-Fi are also hidden. This is where the router does not broadcast the wireless name. But you can see how easy it is to get information about the Wi-Fi access point, so this doesn't give you a lot of protection. It is best to use secure passwords to protect your network rather than hiding the wireless name. At the bottom of the screen are 4 tabs to access different information. I will now select Channel Rating. This will give you a rating of how congested each channel is. In the old days, it made sense to work out which channel was the least congested and use that. However, nowadays, with so many Wi-Fi devices in use, network conditions can change quite quickly. Shown here are the different channels for the 2.4 GHz band. You will notice that the channels overlap. Thus, adjacent channels can cause interference with each other. Not all channels are available in all countries. For example, channel 14 is generally only available in Japan. The 2.4 GHz band is also used by a lot of other devices, including Bluetooth, cordless phones, baby monitors, and microwave ovens. If you wanted to select a channel, in this case the best channels are 11, 12, and 13. To get a better idea of what devices are on the network, I will select the tab Channel Graph. This will show the Wi-Fi devices in the area and their signal strengths. The last tab is Time Graph. This monitors the signal of the Wi-Fi devices and plots them on a graphic over time. With so many Wi-Fi devices, this can be difficult to read. I will conduct a Wi-Fi survey using the software from NetSpot, and I will be using the Android mobile application. This is available on Google Play and Apple Store. The free version will not do heat maps, so you need to pay for the premium version if you want that feature. Compared with other products, it is not that expensive. There is also a full application available from their website. The cost of the application is a lot more, so if you just want to create a heat map, the mobile version could be a better choice. Let's have a look at how to use the application. To test the application, I am connected to a public Wi-Fi network. I will walk around the area and see how good it is. The application has 3 features: the heat map option, Wi-Fi inspector, and speed test. Only the heat map option is not available in the free version. When I select Wi-Fi inspector, this will open a list of all the Wi-Fi access points in the area. You will notice that there are a lot of them. The area I am doing the survey in is surrounded by stores and residential apartments. I will be testing out their public Wi-Fi to see what coverage I can get. I will go back to the main screen. I have already connected to their public Wi-Fi. Software like this requires you to connect to the Wi-Fi that you want to use. I will next select the option Speed Test. This will test the speed of the Wi-Fi and is just like a speed test that you would do on your computer. Once complete, it will give you the speed of the Wi-Fi connection. It will also give you the response time for a ping. In this example, the ping is 3 milliseconds, so the response time is quite good. I will now go back to the main menu. I will next select Create New Heat Map. This option is only available in the premium version. If you don't want to spend any money on an application, I will look at how you can use the previous free application to do a basic site survey. I will be asked if I want to add a picture or a map. In this case, I will add a picture of the map of the area that I will be heat mapping. The application will ask you to set the scale. To do this, you will need to select 2 points on the map and enter the distance between them. Select 2 points that you know the distance between, and the application will scale the map accordingly. the application will require you to move to different points on the map and take readings. Press the Scan button and the application will take a reading. Then move to the next spot. I will walk to the next spot and then press Scan to take another reading. I will keep moving to other positions, taking a scan at each point. You will notice I get a message saying that throttling is on. Throttling limits how often Wi-Fi scanning can happen. This is done to prevent the battery being depleted too quickly and can affect performance if a number of applications are attempting to use Wi-Fi scanning at the same time. There is also a security risk as continual scanning can reveal your device presence to nearby networks. You will notice that when I tried the next scan, it is delayed because throttling is preventing the scan from starting. To disable Wi-Fi throttling, developer options need to be first enabled. This is done by finding the build number in your settings. Different mobile phones will have this in different locations. Once you find it, press it 7 times to enable developer options. Developer options, as the name suggests, enable options that are generally only used by developers. Once you have finished using it, consider changing the settings back and disabling it as you no longer need it. Developer options may be in a different location depending on the device. You want to find the option for Wi-Fi scan throttling. Once found, disable it. Disabling it won't prevent Wi-Fi scans being performed quickly. Understand the risk of enabling the option, and once you are finished with it, consider switching it off. You will notice I can perform scans as fast as I can walk to the next position. This makes the process much faster. I have reached an obstacle and can't continue in this direction, so I will turn around and go back in the other direction. I will keep going until I hit an obstacle again. I will now continue to keep taking additional measurements. You will notice the process is very repetitive and requires you to know where to stop to take the next reading. This may not always be possible. I'm essentially estimating where I need to stop, so it is possible for errors to occur if I stand in the wrong spot. Also, taking this many points is time-consuming and arguably does not help you that much with the heat map for a wide open area like this one. If there are obstacles that may block a wireless signal, it is worth scanning more points, but in this case, the area is mostly open and thus there is not much stopping the signal. I will exit out of here and select the option Wi-Fi Heat Maps. This will show the Wi-Fi heat map for the measurements I've taken so far. You will notice that the signal is pretty consistent, so there is an argument not to make as many measurements as we can't really see any differences. I will now take some points in a circle. I've sped up the video as it takes some time for me to walk between the points. Going around in a circle will give me a good idea of how good the Wi-Fi is in this area. If you are strategic about which points to measure the signal from, this can save you a lot of time. Once complete, you will notice the signal is pretty strong in this area. It starts to reduce a little bit in some areas, but it is hardly noticeable. I will go back to the previous menu. You will notice I have the option to resume scanning. So I will select it and start scanning some points that are further away from the main area. Once again, I've sped the video up as there is quite a distance I have to walk between the different points. Once complete, I will open the heat map. This area has pretty good Wi-Fi, ranging from quite good to excellent. This is an outdoor example. I will next have a look at an indoor example. In this example, we have a one-bedroom apartment. The networking for the apartment is located in a walk-in closet. Thus, this is where the Wi-Fi router has been installed. Although it is good practice to place the Wi-Fi router in the center, often the networking will not be in the center and it may be too difficult or impractical to move it somewhere else. In the living room, there is a TV that is connected by Wi-Fi to the router. The TV often has performance problems, so we are going to conduct a Wi-Fi survey to see if we can find the problem. I will stand near the router and open the application. You will notice that at the top of the screen, I am connected to the home Wi-Fi. You don't necessarily need to connect to it, but it does make it easier in some ways, but there is a caveat. I will now select Home Wi-Fi at the top. This will provide some information about the current connection, including signal strength. But notice that it is currently connected to the 5 GHz band. Since the router is dual band, devices can connect to either 2.4 GHz or 5 GHz. Thus, using this option will only get readings for the band the device connects with. You will notice on the 2.4 GHz band that our Wi-Fi network is shown on the left-hand side and is quite strong. I will now make a record of that recording and add it to my map. This graphic will only show the 2.4 GHz band, so I will select the 5 GHz band. Unlike the 2.4 GHz band, all the channels are not combined together, so I will need to go through each channel till I find my Wi-Fi. I have found my Wi-Fi point, so I will add the reading to the map. You can see that both the 2.4 GHz and the 5 GHz bandwidths have about the same signal strength, but I am quite close to the router. I have moved to the door of the bedroom and will select the 2.4 GHz band. You will notice that the signal strength is about the same. There will be a delay when you move position, so make sure you give the device time to scan the network and make adjustments. If you take the reading too quickly, it won't be accurate. I will now add the reading to my map. I will now select 5 GHz. You will notice that for 5 GHz the signal strength has reduced. I will now add this reading to my map. I will now move to the living room and select the 2.4 GHz band. I've sped the video up a little bit, but you can see it takes time for the signal strength to come down. So before you take your reading, make sure you give it time for the reading to settle. Otherwise, the reading won't be accurate. I will now add this value to my map. I will now select the 5 GHz band. The signal strength is starting to reduce and getting closer to the strength of the other nearby Wi-Fi access points. I will add it to the map. I will now move to my final location and select the 2.4 GHz band. I have already allowed the reading to settle. You will notice that the signal strength is getting very close to the other Wi-Fi access points in this area. The signal strength is good to fair, but not excellent. Most likely the problem with the TV is not so much the signal strength, but the combination of signal strength and there being so many other Wi-Fi access points in this area. I will add it to the map. I will now select the 5 GHz range. You will notice that the signal strength has dropped down to fair. I will now add this to the map. There are as many Wi-Fi access points using the 5 GHz band as the 2.4 GHz band. While 5 GHz offers clear advantages due to its high speed and is generally less congested than 2.4 GHz, its signal strength diminishes more rapidly as you move further away from the access point. Both the 2.4 GHz and 5 GHz bands, in this case, have reduced signal strength by the time it gets to the TV. Even though the Wi-Fi is still fair, it is probably not strong enough for the TV, especially when considering streaming movies which require a lot of bandwidth. To fix the problem, I'm going to add a Wi-Fi extender. In this case, there is a network point that I can use to plug into the network, but there is not one near the TV. Thus, Wi-Fi was the only choice in this case, unless I want to run cables to the TV. While I am confident this will fix the problem, a quick Wi-Fi survey is not a bad idea. In business, these are a good thing to show to the boss to justify the money you spend on a Wi-Fi extender. To do this, I will follow the same process as before. That is, go to the same points as before and get a reading. Notice that my home Wi-Fi appears twice. One is the Wi-Fi router and the other is the extender. For the purpose of making the Wi-Fi survey easier to understand, I will only take the higher value of the two. To compare with the previous Wi-Fi survey, I will add these values to the map. Of interest is the reading I took near the Wi-Fi router. You will notice that the 2.4 GHz reading has gone down from -32 to -18. The reading should be similar to the original reading. It is possible there is just more Wi-Fi traffic than when I took the previous reading, or maybe I just got a poor reading the last time. It goes to show the readings may fluctuate, so don't be concerned if you get different readings from the same place, unless they are significantly different. At the next point, there is not much difference. This is to be expected since it is about halfway between the Wi-Fi router and the extender. At the next point, there is some improvement. Given that the signal strength was already excellent, Thus far, the extender has not provided any real benefit to our network. The last point has the most significant improvement in Wi-Fi signal strength. This has gone from good for 2.4 GHz and fair for 5 GHz to excellent for both bands. This result clearly justifies the purchase of the Wi-Fi extender. We identified an issue on the network, not a complete dead spot, but certainly poor performance, and have evidence that the extender has successfully addressed it by boosting the signal to excellent quality in the previously affected area. If you are having problems with your Wi-Fi, consider taking some readings and moving the access points around, or adding some extenders to your network and take some more readings. Keep in mind that if you have an access point that uses mesh, your devices will change access points a lot more smoothly when they move around than access points that do not use mesh. So, if you are not using mesh, don't be surprised if your devices are stubborn and don't want to change access points, even if there is an access point in range with a better signal. If this is a big problem, you may need to give your access points different names and manually change access points when you move from one area to another. To provide another real-world example, I helped out a friend with a Wi-Fi upgrade for a warehouse. The company did not have a big budget for the upgrade and did not want to spend money on a Wi-Fi site survey. There were old Wi-Fi access points around the warehouse. The warehouse had metal shelving throughout, which is not good for Wi-Fi signals. The metal and the items on the shelving affect the signal. Thus, you want the access points up high so you can try to avoid some of the objects. In the warehouse, Wi-Fi scanners were used for stock management. All the items have barcodes. The scanners scanned each barcode and the scanner would communicate back to the warehouse management system. The problem was, the scanners would regularly drop out, especially in particular areas. In some cases, the scanner had to be restarted in order to reconnect to the Wi-Fi network. When first installed, the network worked pretty well, but then had steadily gotten worse since then. Some of the questions I asked were, where are the network dropouts? How often do they occur? Are some areas worse than others? You want to perform a visual check of the area. Where are the access points? Is there anything blocking the access point? In a warehouse, there are going to be a lot of things blocking them. The question you are really asking is there a better place I can put the access point so less things are blocking them? Lastly, has anything changed? Now that you ask, yes, there have been some changes. Since the Wi-Fi network used to work pretty well, something has probably changed, which is now affecting it. In the old days, the warehouse was quite full. However, the company started using just-in-time manufacturing, which is a production strategy that aims to keep the bare minimum number of items in inventory and produce on demand. As a result, there was a dynamic decrease in the number of products stored in the warehouse. When the warehouse was not that full, that is when the Wi-Fi was installed. Then there was the COVID-19 pandemic, and inventory became harder to get and the company had trouble filling orders. Thus, they started increasing their stockpiles in the warehouse. Because of this, the shelves became more densely packed. So, this would explain why, over time, the problems with the Wi-Fi increased. So, the next step is to work out what to do about it. I next looked at the existing warehouse layout. I was able to visually locate the existing access points. They were located in some strange places. The thing that strikes me is that they are on the walls rather than the roof. Also, they are not quite in the center of the warehouse. When I see things like this, I ask the question, why? Sometimes people will know the answer. At other times, because it happened so long ago, no one knows why. In this case, they did not want to put the access points on the roof due to the extra cost of hiring a cherry picker. However, now they have a cherry picker on site, so that is no longer a concern. The next question is, why were the access points put in these locations? To understand why the access points were placed where they were, let's consider what the warehouse used to be like. Previously, there were fewer shelves in the warehouse. Also, the office was located inside the warehouse. Since there was space, the forklifts were parked in the warehouse. As time passed, to add more shelves into the warehouse, the office and forklifts were moved outside. You can see the old design. It made sense to have the access points where they were. However, with the new shelves, they are no longer in the ideal locations. I conducted a Wi-Fi survey and identified the following areas of poor Wi-Fi reception. The far left has fair Wi-Fi, while the far right is weak. Speaking with the staff, they confirmed most of the problems are in these areas. The solution was to install 4 new access points on the roof that use mesh. Since the Wi-Fi devices move around a lot, you want a Wi-Fi solution that will allow the devices to switch access quickly to take advantage of the access point with the strongest signal. The access points were moved to the roof so the Wi-Fi signals could be distributed around the metal shelving without being blocked as much. Once complete, it is not a bad idea to do another site survey so you have some evidence that it is working as expected. In the real world, professional wireless surveys cost money. Simple wireless surveys may only cost a few $100s, whereas complex surveys may cost thousands of dollars. If you are installing Wi-Fi in a warehouse, as in the example provided, often it is pretty easy to justify the cost to a business compared with the loss of efficiency if the Wi-Fi does not work very well, especially when you consider how long the Wi-Fi installation will most likely be used for. When you pay for a Wi-Fi survey, it is most likely to be done using professional hardware and software. Depending on what is used, it can cost thousands of dollars just for the software. The software also takes a bit of time to learn because it can be pretty complicated. This software will also be able to generate wireless heat maps. The more advanced software can also take into account walls and other obstacles. Hiring a professional also gives you additional knowledge and experience. Although using the tools I have looked at can enable you to do your own survey, on some sites the survey can be very complicated. Having someone who has done a few wireless surveys before can be invaluable. Many companies will also recommend solutions. They may also be able to supply the equipment and install it. They may also give you a guarantee and a warranty. If you have problems with the Wi-Fi after they install it, they may come back and fix it for you. If the total price includes the Wi-Fi survey and equipment, your boss may be more willing to accept it. Generally speaking, Wi-Fi works well when set up correctly. Most of the time when I have troubleshooted Wi-Fi, it is either configuration problems or the access points have been put in the wrong place. Moving an access point or changing the configuration can often help. If you are not using it, consider using mesh for your access points if you have more than one. Mesh really helps when your devices move around. The standard Wi-Fi protocol is not good at changing access points when devices move around. 2 network engineers are arguing over the best tool for a Wi-Fi survey. One says, "I prefer a heat map. It gives a clear picture of the problem." The other replies, "I like the signal meter better. It's more user-friendly." Suddenly, the building's power goes out. Both engineers look at each other and say in unison, "Maybe we should have started with flashlights." Thanks for watching.